Hey guys, welcome back to Study with Ming, and today I'm going to show you guys how to memorize the most common MacLaurin series that you would see a lot on the AP Calculus BC test. Okay, so without further ado, let's get started. So our first MacLaurin series is, well, for the most basic series, going to be 1 over 1 minus x. And this is like the base series that you need to memorize. Like when you can memorize this, you can use that in order to come up with other MacLaurin series for other functions as well. So this is our first function, and the MacLaurin series for this function is really simple. It's basically just going to be 1 plus x to the power of 2 plus x to the power of 3 and x to the power of 4 and so on. It's really simple. Okay, and so now we need to find the next really common MacLaurin series is for the function the natural log of x plus 1. But we can actually come up with the MacLaurin series for this function by looking at our series right here. And I'm going to show you guys how to do just that. Okay, so first I'm going to replace the minus sign here with the plus sign. So I got 1 over 1 plus x. And basically we just substitute minus x for our x here. So I'm just going to change, I'm just basically going to, I'm going to change the sign here. So that's going to be 1 minus x plus x to the power of 2 minus x to the power of 3 and plus x to the power of 4 and then minus and then so on. So now I'm going to find the antiderivative of both the sides of this equation, and that I would come up with something like this, right? And because we're using positive x, so I'm just going to use this bracket right here, and that's so the antiderivative of this series is really easy because when you know about integral and antiderivative, you know how to do that, right? So the antiderivative of 1 is going to be x minus x to the power of 2 over 2, right? Plus x to the power of 3 over 3 minus x to the power of 4 over 4, and then so on. So this is what we have, okay? So next, let's take a look at another really common MacLaurin series. Let's take a look at this function, e to the power of x. So it's a little bit different here. So I'm going to remind you guys of the formula for MacLaurin series. So our MacLaurin series is going to be the sum of f of n, right? It starts from 0 over the factorial of n centered around x equals to 0, and then we're going to multiply that with x. So basically it's going to look something like this. Okay, and I'm sorry. Okay, it's going to look something like f prime of 0 over the factorial of 1, and we're going to multiply that with x, and then so on. So basically, this is what the MacLaurin series is like for all functions. So you can see that e to the power of x, no matter how many times you differentiate it, it's always going to be e to the power of x. And when x is, for the MacLaurin series, x is always centered at 0. So e to the power of 0 is always equal 1. So because of that, we can easily come up with the MacLaurin series for e to the power of x. And so it's going to be, so the first thing is we're going to multiply that with 0, right? So it's going to be, I'm sorry, we're not going to multiply with 0. So the first is going to be e to the power of x when x equals to 0 over the factorial of 0. And the factorial of 0 is 1. It will be 1 over 1. It's going to be 1. Okay? So this is the first term of the MacLaurin series for e to the power of x. And then we're going to plus the next e to the power of 0 over 1, the factorial of 1, and we're going to multiply that with x, and this is 1, right? This is 1. So we're just going to write x. Next, e to the power of x, e to the power of 0 over the factorial of 2, that's going to be 1/2. And we're going to multiply that with x to the power of 2 and the factor of 2, okay? And next, the same thing is going to be e to the power of 0, and we're going to multiply that with x to the power of 3, and it's going to be over the factorial of 3. And so on, we have this. This is exactly the MacLaurin series for e to the power of x. And this will become really handy because in some question, they might give you the series over here, and then they will need you to evaluate it. And if you memorize the MacLaurin series for e to the power of x, it's going to be really handy. So let's take a look at one specific example of this so that you guys would get a hang of it. Okay. So our question is, we're going to find the value of this series. Okay, so imagine there's a question asking you guys to evaluate this value, and how can we do that? Okay, so when we kind of do that, so this reminds you of something, we can rewrite this MacLaurin series for e to the power of x to something like this. So this actually x to the power of n over the factorial of n, right? So you can see that we can compare this with this. So basically, we're just going to replace our x with 1 over here, and then so it's just going to be 1 plus 1 plus 1 over the factorial of 2 plus 1 over the factorial of 3, and so on. And then it's definitely going to be e to the power of 1, and it will be equal to e. Well, yeah, so it's kind of like that. Wait, hold on. No, it's not like that. I'm sorry. This, because our index here is actually 1, and our index here is actually going to be 0. So there's a change in the index, so it's actually e to the power of 1 minus 1, because we're lacking something. We don't have 1 over here. We only have one value of 1 over here. Yeah, and it will be this. We don't have this. So remember, okay, it's a little bit tricky when you see the change in index. So, but I hope that you guys are getting what I'm saying. So by memorizing these MacLaurin series, it will come really handy in your exam, right? So make sure that, so I'm going to rewrite that in the form of a summation. Okay, so we have e to the power of x here, and then so we have covered some really common functions, and so now let's talk about trigonometric functions. How about sine x? What is the MacLaurin series for sine x? We can actually use our definition of a MacLaurin series. Okay, so first we're going to, so basically f0 is f0 here. I'm just gonna rewrite that. Yeah, so f0 So sine 0 is 0, right? Sine 0 is 0. So we will skip the first term of that. So we're gonna start with this term. And so the derivative of sine x is cosine x, right? And cosine 0 is 1. So 1 over the factorial of 1 multiplied with x, so we're going to start with x. Okay, next, we have this is cosine x, right? So the derivative of cosine x is going to be minus sine x. So remember, there is a change in the sign of the terms, so we're going to have to minus. So next is going to be x to the power of 2 over the factorial of 2, right? Oh, I'm sorry. There must be some mistake. Must be some mistake. I'm sorry. I forgot about something. Yeah, so here we're going to rewrite that. That's going to be minus the cosine of 0 over oh, it's actually cosine x. Yeah, and we need to take the derivative of it. What? Okay, so we start with x, right? And then I'm gonna draw the graph of sine x. It's gonna be something like this. Oh, yes, and so you can see that. Actually, we need. It's going to be minus x to the power of 2. I'm sorry, x to the power of 3. So like you actually skip the two terms because here, this is minus sine x, right? And minus sine 0 is 0. So we're going to skip this term. We're going to skip this x to the power of 2. So we're going to jump straight into x to the power of 3, and that's going to be cosine again. But, the sign, the sign changed negative. So that's why we have our minus sign right here. And that's going to be x to the power of 3 over the factor of 3. And then we're going to skip the next term because that's when sine 0 is, right? That's where sine 0 is. And because there is change in sign again. It's going to be positive, and then x to the power of 5 over the factor of 5, and then minus x to the power of 7 over the factor of 7, and so on. Alright, that's really easy, right? Okay, next for cosine x. We're going to do exactly the same that we did in here. So for cosine x, so first, cosine 0. Cosine 0 is 1, right? So we're going to start with 1. And then cosine 0, the antiderivative is it's going to be minus sine 0, and so we will have to skip this one, right? Because sine 0 equals 0. And this is going to be minus cos 0, that's going to be minus 1. So we're going to have our minus sign. Okay, I'm going to put our minus sign here, and that's going to be x to the power of 2 over the factor of 2. And then we're going to skip the next term because that's where sine 0 is. And sine 0 is equal to 0. Okay, and there's also a change in the sign as well. And this is going to be x to the power of 4 over the factor of 4, and then minus x to the power of 6 over the factorial of 6. And it's going to look like that. So we can see that the MacLaurin series for sine x and cosine x are really similar. They're just like odd and even numbers or something like that, right? So you guys can easily memorize. So I think that the easiest way to memorize the MacLaurin series is to memorize like its formula. But if you guys know how to write the MacLaurin series for these common series, that's going to be much more convenient for you guys. Okay. So these are the most common MacLaurin series, and thank you so much for watching my videos. Please subscribe to my channel for more videos like this. I hope that this is this is helpful for you guys. And well, good luck revising for the exam. So it's the end. Bye bye.